Howdy, everybody. We're here for day 7 of Advent of Code. It's too soon since I solved day 6, so I haven't even really looked at refactoring it. It's Saturday morning here where I'm at, so my goal is just to try and solve day 7, hopefully in just like an hour and a half or so, because I have a hard stop. If that happens to be the case, I guess we just maybe I'll finish solving it and I'll send out a video of like me finishing it as opposed to just like the live solve. Okay, so day 7 bridge repair. The historians take you to a familiar rope bridge over a river in the middle of the jungle. Some of these I'm almost sure I've solved. Have I solved this one? Yeah. Okay. You notice a group of engineers are trying to repair it. You ask how long it'll take. They tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators. There was an elephant one, huh, when we were helping elephants? They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators in their calibration equation. Your puzzle input. Okay, so here's the test examples. Just load that right now into here. Okay, let's see. No, I do not. Why is that up there? I do not want to ask him. Each line represents a single equation. The test value appears before the colon on each line. Okay, so this is what we're testing for. Your job is to determine whether the remaining numbers can be combined with operators to produce the test value. Just like these two. Okay, so like this one would work because you could multiply them together. This is some big number, but potentially you could like add, let's see. They're always evaluated left to right. Okay, so we're not doing like PEMDAS type stuff. And then we add or multiply are the only two types. Okay, so no subtraction division, which means we can use larger numbers like a U size. So this one works because you can add or multiply these two. Oh, that's interesting. It works either way. Multiply these two and then add these two and multiply. The engineers just need the total calibration results, which is the sum of the test values from just the equations that could possibly be true. Okay, so the gist is we're going to try and add or multiply these numbers together, always from left to right. That's a key because it means we could probably do some kind of recursion. And see if we can get to this number. And if we can, then it's a valid one. And we can then we add up all the valid ones to get our part 1. That doesn't seem too hard. How crazy are the inputs? Okay, really big numbers. I mean, not really, really big, but hundred thousand million billions in the billions. What is a U64? Oh yeah, U64 presumably has enough room. Like what I'm thinking is, so when you're doing recursion, the first thing that should come to your mind is, like back in the day, or when I was taught it, it was like, what's the sentinel case? Like, what's the condition in which you stop? And so obviously we'd found it if we found this value, or we'd know that recursing that decision tree is not correct because we've exceeded the value. And it doesn't look like any of these numbers are like so big that you'd ever. So if we just use a U64, we should be more than fine. Okay, we'll save the input and we'll just start coding. Ooh, I wanted to use nom for this, so should we do some parsing? We could say like we could create a, what are these called? Like a test or whatever. And it would be the calibration and the values, which is a vec. And so we'll create a parse that takes an input stream and returns itself. But I want to use nom. So this is actually going to return a I result. Which I think looks like that. Map res to a digit 1. I actually don't know what this is. I think it's simpler than that, right? You can just do like these things right here where we want like the colons, and then we do calibration equal digit 1 input. Is it because digit 1 one or more ASCII numeral characters? Okay. And then we get rid of the colon in the space. I gotta fix this, the quick fix to Oh, is it bytes complete tag? Okay, so we have the digit, then we have the colon and the space, and now we want a series of numbers. Like this. Does it have a refactor button here? Yeah. Oh, these are all strings too. Interesting. Nope, it's a U64. Same thing with the values. Do the same to those. Okay, so we did all this work to use num, but then we still have to parse them. I wonder if I can trigger an I result or get an I result to do this. We can figure that out later. Okay, but now we have our test input, and let's just like do that, and then we'll just print them out just to make sure they look okay. $90, $10, $19. Yeah, okay. It looks like it's done it. Okay, so now we have our values. So what is the simplest case? Let's assume there's a function called is valid, and you give it the calibration, which is a U64, and the values, and you say whether that is equal to it. Right now, we'll just return false and say it's not. Then all we have to do for part one is say we want a sum of the values. So we can say let P1 equal test it or fill. Okay, is it going to do it for us? Is valid, but we don't actually want the count. We want to map it to the calibration value and then do a sum. Okay, there, it got it. And then we'll print part one. Like that. So presumably this right now will print out 0. Oh no, that printed out all of them. There you go. Okay, so now we just have to do this recursive function, right? So what is the base case? If we say if values dot len is equal to 1, return value 0 equal calibration. So this is our like edge case, or one of our cases is we say if there's only one value left here, we've done all the arithmetic. Let's check and see if it's equal to our calibration. Else if what would be the other edge case? If there's no value, we never have a case where there's no values because we're checking it with one value here, right? We could also like short circuit and say if we ever get to a case where where this one, the first one is bigger than this one, so we could say like if value 0 is greater than calibration, we return false. We know that one's a bad case. Are we missing any strange cases there? We can add the 0 case. Oh, it's just mad because I haven't finished this. So try adding value 0 and 1 and seeing if that's valid. And we actually want to like put that sum into the new values array. So like you replace 0 and 1 with the new value. So we say like hold on a second. Okay. I've got some kids that love Minecraft and they are constantly asking me to create new servers. It's really cute. Okay, but we want to so we create a new vec of values and we say let left equal, let right equal. So now we've removed the 2 and we say we add them. I wonder if there's a faster way to do this. There is like a push front pop back in things like in vectors and stuff like that. This probably has the same effect. But we can say check if this one is valid. But it would be calibration minus value 0. Oh, no. No. The calibration never changes, right? Oh, I could have it do it, right? If I remove these 2 values, and say calibration minus left plus right. Else return is valid calibration minus left times right. No, I don't even need to change this. New values. Right? Like okay, so here's what I'm thinking is at this point we definitely have two values in the vec, right? So if it's 0, it's here. If it's 1, we're testing if it's equal. If we ever or if we've ever gone too big, we know we're gone because we're only adding or multiplying. So this part is only getting bigger. Yeah, this part doesn't work. I'm trying to think this through. Like my thought was, oh, can I just slowly remove values from the calibration? But the way that would work is you're testing if the calibration is ever equal to 0 and there are no values left. So that's not it. The test for valid is we're gonna pop these two numbers off. Isn't there a pop front? It's in a vec DQ. Ooh, should we treat these as, or I think you say them vec dex. Do that. And do that. Then we clone. And then we do pop front, unwrap, pop front, unwrap. So we have the two values, and so we can just do these two cases where we say new values dot push, no, push front, left plus right, and then we say if is valid calibration new values, return true. And now we want to do the multiplication of it. So we just do new values dot pop front. And then we new values dot push front left times right. And now we just return is valid. Boy, that's annoying. It's got the spelling in there. We'll just add it to our dictionary. Okay, so what does this is valid do? We're going to do it recursively. So we have our base cases where we say if the length is 0, then we return false. Is there a weird case here? I don't. My thought was, do they have a strange corner case where there's the number 0 right here and there's no values after the colon? There is no 0 at the beginning. Okay, so that's not the case. Sometimes it doesn't hurt to test the input values. You can find like special cases where you may not want, where you may have to handle, or you can find that there's not those special cases and you don't have to worry about it. Okay, so this probably will never trigger, but if we say the length is 0, we return false. If it's 1, we just return if the last value in there is equal to the calibration. If we ever get to the point where we've gone too far, then we know that we return false as well. Otherwise, we create a new value set. We put push pop, and test. Ooh, should I make this mute and then we don't have to make a clone? So we pop off the 2, test it. Then we pop off this one and push this one back on and then test it. Can I borrow you as visualizes is not declared as mutable? Am I doing this wrong? I need to declare it as mutable. I have no idea why I don't think that's right. Is it like I have to do an intermute here as well? We're going to figure this out. It's just my infamiliarity with Rust. Consider changing this bindings type to be mute. What the heck? That can't be it. Okay, maybe I don't do all of this. Like, I really wonder why that's not. Just because it doesn't live long enough? $56.62. Oh, it's already mutable? I don't have to do this. Is that the error? Yeah, that's the error. Okay. 3749. 3457. Okay, that's not the correct answer. So let's see which ones I'm getting wrong. $292 is the last one. Doesn't find 292. $11 plus 6 times 16 plus 20. So it does find these first two, but it does not find this one. 3457. 292. 11 plus 6 plus 16 plus 20. It's possibly that I'm, let's see. I pull off the two values, and then I push the addition, and I run a test. And then I pop off this initial value. And I run its test. I'm going to try it without the mute because I almost feel like that's what's happening here. But let's just try it. Doesn't that rename work all the time? At least not the way I'd like it to work. It's probably working the way it should. I'm just not doing it correctly. Okay, there you go. So why doesn't that work in the last case? What is the mute doing? I pop up two values and I push the addition, I do the tests. Oh, if it returns false, I need to rewind is what it is. So like like that. I need to rewind if we're invalid. I mean, I can add this, but like if not valid. because it's going to, there's going to be cases where it's going to try and go through. Okay, and so now I should be able to make these mute. Ooh, what was that? Yeah, there we go. Okay. So it was just that you this is the thing with recursion. If you're, this is not, I mean, because I'm using the same vec, it changes kind of the nature of it. Um I'm mutating this value at each recursion. So if I ever go back, if I ever get to a place where it's false and I need to go back up, I need to like rewind, right? So if we need to put the values back because the call above will expect to have the original values in, like that. Okay. Okay, so let's try it with the input. Okay, part 2. The engineers, oh, well, maybe we should just review really quick. We use nom to like pull the values out. It would be nice to fix these unwraps. My guess is we could probably fix the unwraps. I like doing something with this I result. I know you can tell it what error you want it to return. And so we could, I wonder, does it just work if we just do this? I wonder if someone's already figured this out for me. I have seen these type of things where you like join the errors together. Inom error kind. Okay, I won't dig into this too much. There is a way. I'm pretty sure there's a way. I'd have to go look back in some old code. If you know it, I'd love to hear in the comments. Like how do you add these? And I vaguely recall it's like you can do like an unwrap or something like that to convert it into an I result, or you can create an error that encapsulates both of them and have this return that error type thing. Anyway, otherwise we just parse it, and then for each of them we test if they're valid, and if they are, we sum up the calculations, right? So the filter is it valid? I have some, I guess we can get rid of this. And we can just return this. It'll probably look a little cleaner. So we test if it's valid, and if it is, we get its calibration and sum all those up for part 1. And again, this is just a recursive call where we're trying to add or multiply the first 2 numbers. And so we need to, whenever you're recursing, you need to think about the sentinel cases, or like the cases where you should stop. And in our case, if we ever run out of things, we know we probably haven't got an answer. If we ever have exactly 1, we know we either found it or we didn't, based on whether that value is equal to the calibration. And if we ever get to the point where our number is too high, is bigger than the calibration, then we know we can't get anywhere there because, so we just return false, right? Okay, so and then what do? We pop off the two values, try to add them and see if that works. And if not, we pop off that value, try and multiply them and see if that works. If it doesn't, we roll back and return. Okay. The engineers seem concerned the total calibration results you gave them is nowhere close to being within safety tolerances. Just then you spot the mistake. Some well-hidden elephants are holding a third type of operator. The concatenation operator combines the two digits from its left and right inputs into a single number. For example, 12345 would be 12345. All operators are still evaluated left to right. Now, apart from the three that could be made using addition and multiplication, these ones work. Okay, because you can just concatenate 15 and 6 together. So you literally do like a string concatenation, and now you get a new number. Multiply these two numbers. So 48 gives you, and then you cat that 486 times 15. Okay. 178 plus 14. 192, yep. Okay, so we're just adding a new operator. These numbers aren't big in the test case. How big are they? Like, how many times can you concatenate? Like, could you just concatenate them all? And does that create a really big number? I don't see any. None of the lines are too big. My concern is overflow. Like, one thing you just think about is like, am I going to overflow if I just concatenate a bunch together? Or do a bunch of multiplies and then a concatenate? Probably not overflowing. We'll see. Maybe I am. So what we can do is we'll go back to the test input and we'll add another function to this value where we say this, and for part 1 it's false. Okay, so this would just run as normal. 3749, I believe that was. Yep. So now the question is, we do this for part 2, same thing. We just change this to true. And so if it's true, we want to try it maybe after the multiply. Why does it know that? Maybe just because we already have the left and right values, right? We have left and right. So we don't need to do this part. We just push the two numbers together, parse unwrap, add that to our thing. If is valid. return true. I don't, so here we just assume that it's not valid. And we can just go like that. Maybe that's an easier way to do it. The number's lower. That's not right, right? Part 2. Oh, we need a pop front. Right here. There we go. 11,387. Yeah. Okay, so all we've done is we've added this third case where we say, let's try and concatenate the two numbers and then push that on and test if it's valid. I mean, the way it's going to be slow is if there's some... It does have the potential to blow up the recursion. And by blow up, I mean like really expand the recursion tree, because you used to recurse 2 times. Now you're recursing 3 times. And so it was n squared and now it's potentially n cubed. Should we see how long it takes to run? We may have to look for optimizations. Was that my first one? 265. I mean, that ran really fast. Oh, okay. I mean, there you go. Was that really it? Okay. There you go. Not too bad, especially compared to yesterday. I really struggled with some of the edge cases. Let's go before I go look at what everyone did. Is there anything I can do to like clean this up? Yeah, I can work on that nom thing. I like using the mutable one because I'm not copying a bunch of times. I don't know how much time that saves you. I'm curious if anyone else did it in Rust and they just copied their vex for each of their recursions, what they got. That would be interesting. This is not super clean. It's probably faster though to do it. Like my thinking was, do you want to leave the integers as strings, but you do more parsing this way. Presumably this is the last case, and so you're doing the formatting and parsing less just for this third case than you are if you had to format and parse for these 2 cases. So probably doing it in that order's faster. We can time this too if we want. See how long it takes. I mean, it still runs in a quarter of a second. That's not long at all. Like, what are the optimizations? Sometimes you go faster if you do... let's look at the input. No. I mean, you'd have to do an analysis, but sometimes you can discover that, like, your edge cases are faster if you do your recursion backwards. You do, or use like tail recursion, not tail recursion. You have to do the arithmetic on all the numbers, and so sometimes you can say, oh well, these numbers over here have a higher propensity to affect the outcome, and so I should start here first because it'll help me short circuit faster. But I can't really tell. You do see some large numbers at the end, but you also see some at the beginning, so it doesn't really help you there, I guess. Okay, I just want to spend like 2 minutes with the nom. What is it? Is it a map? Nom recipes. Nom nom nom. Literal values, integers, hexadecimal. Here we go. Map res. Applies a function returning a result over the result of a parser. Map res digit 1. Okay, that's exactly what I want to do. So this would be so we want to map res digit 1 U64. What is the quick control period? Separated list and what of map res do the same here. Can I just do into? Please? Yes. Boom. Okay, that looks a little bit better, right? So I'm just saying I use map result, which is like saying I still want to get a digit, but every digit I get, I'm going to call parse on it. And if it's ever an error, this map res will return an I result. Okay, very good. And this feels clean to me, right? I'm not a fan of the whole unwrap stuff, so this feels fun and clean. I should say I don't mind unwrap, especially when you're doing these games and puzzles, just because it's a game and a puzzle, and it's okay if your program blows up. Obviously, if you're running production system, like you really don't want your program to blow up. So you should do error handling, right? And so in this case, I'm doing all the error handling. Where else am I unwrapping? It's probably down here somewhere, huh? Oh yeah, I do the pops. I don't know. These ones are potentially okay because at this point, you've done your sanity checking and you know that there's two. This one's potentially not safe because you're like, I mean, it is because you know what the input is, but it's potentially not because you're unwrapping this parse. I don't know. It really wavers back and forth, right? Either you can like argue either. I think I could argue either side of it. I think there's cases where it's definitely not okay, right? So presumably this one is you're reading from user input. And so from a security perspective, you'd say, oh, I can't unwrap here because that would definitely be a security issue, is like I'm getting some kind of user input. Of course, again, we're here in a game. So, okay, let's just look at some answers really briefly in Reddit land. Did I lose the Reddit stuff? Nice. First recursive solution. Yeah, it was recursive. You checked the exit conditions, right? Okay, there you go. That is a common problem with recursion, right? Is like you just you miss some of the cases. Like for example, if I miss like popping and pushing values, like let's say I push a value but I don't pop it, and so now my thing is just continually getting bigger. It'll go on forever. Or you never actually pop it, it goes on forever. Or you're not checking some of those sentinel cases, right? Where you don't say like, oh, if I don't, like if you're never checking if you don't find the answer. Rust programmers watching non-Rust programmers taking too long to process part 2. I don't think this is a particularly difficult one, right? Does execution time matter here? 2 seconds in Python. I mean, that's still pretty good. We'll have to look at this. Python was working fine for me for part 2. Adapting my solution took me 2 minutes. The only thing I had to do was add extra functions to my list of operators. Returning early after one of the conditions was true, or returning early if the calculated or exceeded the expected one. Oh, okay. I mean, I don't know that that's a programming problem, right? Like if you just missed this case, that would take you longer because you would keep, basically what this is like a short circuit, right? Is like if you've chose multiply all the way down and it's really big and the number is getting really big, you'll spend a lot of time in those cases where you didn't even have to try because you already knew you'd gone too far. So it is important to find these correct cases. Yeah, this is not a property of the language, though. That's an algorithm issue. It's just something where you have to say, oh, I missed this condition. Compile time and execution time in Rust is much likely longer than running time for Python. Yeah, I don't think it. I don't know that Rust or C or C++ like nets you speed. Has that ever been true in any of the Advent of Code days? Like the only way it would actually be true is if there were like some memory intensive things going on and the compiler is able to figure those out better than the Python interpreter. But I don't know that there's ever been a day where you said, oh, if you did it in Rust, you were able to solve it in a more timely manner. I don't think that's been the case. In fact, if you look, most of the fast solvers do it in like Python. There's some C++ guys there that are really fast. Mostly because they're just used to C++ and the STL is really good, right? If you're going to blatantly break site rules, maybe don't publish the proof on GitHub. What is the leaderboard like? Are there a lot of people cheating? And by like cheating, hmm, I mean, I just don't know. Some of these people I look familiar. And so it's not unreasonable to be like, could they solve it in 2 minutes? Yes, you could. Like I use Rust and I'm, I am not fast. So I kind of I like to think through the puzzle and spend a lot of time. But I feel like especially if you're using something like Python, you could probably solve this in 2 minutes. And you're just like type, 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 2 minutes, you're done. Um 49 seconds is really fast though. Holy cow. Where is his stuff? Is he not posting them? I think this is one of the guys that it could be. He could easily be doing it in time. Although he's only posted his first 2 days. Like if you're a speed coder, for example, this right here, you could easily get that in 2 days, right? Or in, where did he get it in? 1 minute? Yeah. I don't know. It doesn't feel fun to do it this way. I don't know. Are the site rules? Do the site rules actually say um I mean it says until the leaderboards are full to do most or all of the puzzle solving, like handing the puzzle text directly to an LLM. Okay, so he is telling you don't do it. Yeah. He's written a program to ask Claude how to solve it. Interesting. I mean, what happens if I just, I've asked Claude stuff before. Uh, calendar, day 7. Can solve equations. Does this actually solve it? Evaluate equation. Okay, this is an interesting way to solve it. It looks like what Claude is doing is saying, I'm going to take the add and multiply operators and create like a bunch of them, right? That this product is like the cross product where you say, okay, I'm going to create, let's say there's 10 numbers. I'm going to randomly, I'm going to create a cross product of 9 operations, meaning multiply and add. I'm going to do all the Cartesian product of those 9 ones and then evaluate and see if it's true. And if it's true, then I go and do the test with all the operators and see if they're equal. And if it is, then I found the result. This is not what can you solve it using recursion? I mean, that way actually works, right? If current value is none. I mean, I'm not going to read the details, but it looks like it's largely got it. It's going to try to add the numbers and solve recursively and see if it got there. Yeah. Okay, these things are getting really smart, right? So let's see what people say. What is Wheaton's law? Don't be a dick. Okay. Just enjoy the challenge and ignore the leaderboard. This is what I do. I mean, there is a problem because there are real people that enjoy being first, right? I can't stay up in the middle of the night. It's actually not quite the middle of the night for me, but it's essentially that. I can't stay. I don't usually stay up that late, so I'm not there for the leaderboard. So I've never even considered trying it. There's been a couple times where I've thought, oh, can I just do a speed solve and I'll do my own timer and see where it would place me on the leaderboard. But yeah, I think it is going to be a problem, and I don't know how you fix it. Like, how do you know if one guy who solved it in 2 minutes actually solved it? Because there are people even before the days of AI that would solve these, sometimes in under a minute. And you can watch the videos of some of them where like problem one, they've uh they've solved it in like 30 seconds, and then part two takes them like another minute or whatever. You have to be good about problem solving with those things though, right? Keeping track of 2 to the n options, keeping track of 3 to the n options. Yeah, this is what I ran into. Is it 2 to the n? I think it's like n squared versus n cubed. Oh, but why are you keeping? Okay, so maybe these guys solved it more like Claude and they used the product. Yeah, am I missing something? It feels like these guys are using Like, why would you get 2 to the n or 3 to the n? It would be if you were doing like the cross product like Claude did the first time. And so the trick, so maybe if that is the problem, if you're saying, oh, I'm just gonna take a bunch of operators and try them and see if it works, that is not fast for sure. You definitely want to. This one is definitely a recursion one, and recursion is used a lot in these advent to code problems. So I just keep brute forcing and it keeps working. Enjoy it while it lasts. Okay. A times 10 to the power of ceiling log b to the 10 plus b. What? Oh, this gives you the. This has the effect of shifting a by uh that many numbers. So like say a was 1 and b was 1, you times a by 10 and then add b to it, which has the effect of doing that. Okay. Yeah. My language is fixed on I32. Ooh. Could you do this in a U32 though? Klingo. Huh. Okay. Yeah, you definitely will have problems with this if you're I32. That's why I used I64 or U64. Again, though, you might get away with that with a larger thing. Okay, me brief forcing next task at AOC. This is the way. I don't think you have to brute force it. Y'all got any more of them inefficient solutions? Are people just. What is the brute force? Is it just to try all possibles? Okay, let's look at some actual solutions and then we'll be done. Should we look at a C sharp one? Read all lines, split by colon, split by space and parse. Yeah, why is that? It does look like they're not using recursion here. Literally just trying all the operators. Okay, so that is the thing. If you thought, oh, I just have to try all of the various operators and see if that works, probably not going to help you. you definitely want to use recursion. Interestingly enough, I mean, recursion is you learn it like, at least I did. I think mentioned before, Lisp was one of the first languages I learned. You learn recursion very early in computer science courses, and it's huge. You would be surprised how many programming, like, um what do I say, programming problems that I give for like interviews and stuff like that. The answer is just use recursion, some form of recursion. And I say that to just say you should probably learn recursion if you haven't. I think I've done some videos on it, but yeah, he uses format and concatenate. I think that's probably the right way to do it. Um, iter tools, repeat n operations, Cartesian product, any. Okay, let's look at this. Okay, he used the trick. This is an interesting like math way to do the concats. If you have two numbers, you can do the log to figure out the number of digits and um basically like shift that number over. So yeah, that works. Self concat equations build. Yeah, I mean this is a normal way to build the equations. Um, it's using all the unwraps. That's why I wanted to try nom. Is like, can you get rid of the unwraps? Like what nom does is essentially hide the unwraps. It says, "Oh, if anything fails, I'll just return an I result," and then you just have to unwrap that I result. In fact, you can see that in my code is like this part looks cleaner, but then I down here I do unwrap one, right? So potentially I could pull that out too if I wanted to. I mean, I could try and run his solution and see how it compares. I don't. Again, I think one of the things, if you're familiar with like the advent of code or problem solving, there's always going to be multiple days where you're using graph theory. There's multiple days where you're using recursion. There's some days where it's just, can you follow the instructions? And so you just keep your mind as like, oh, is this a recursive solution? Excel. Pretty proud of my one cell solution today. I actually think I helped someone last year with Excel. This name doesn't look familiar. They had or actually it was like a Google sheet, and they had like they were missing one thing, and I helped them find the solution to it. But it's crazy what you can do with like Excel and that stuff. Perl. Don't want to read that. 20 years. Man, that no CSB is starting to get me. I had to essentially just stare at the problem for long enough to figure out that you'd probably need some sort of recursive technique to solve it. Go on Google and find out that recursive backtracking is a thing. See a tutorial somewhere where someone explains the concept of random leak code problem, then try to map the problem. This one seems like I'm starting to reach my limit. Let's look at his solution. Total target with concat. Man, I always forget the split ones. Oh, I guess I was using nom this time, but split once is a good idea again, because you have like two halves to the problem, so you can just parse one and then join the others. Check row. What does check row do? Backtrack. So you give it the values in the target. Okay, so this is like a helper for your backtrack. Let's see what his backtrack does. If I equals input lane, result insert, solution, return, solution push, input backtrack. I'm trying to think this through. Is this recursion? I mean, it is recursion, but it looks like what he's trying all possible values, right? It looks like he's putting like all the results of all the solutions in there. So he is using recursion here, right? He's like trying to he's saying, "Oh, what happens if I multiply? What happens if I add?" And then put those solutions into this result thing. And then at the end he just says, "Does my result contain the target?" So that's okay, but like what you could do as an additional case is just instead just pass the target here and check, right? If you ever like find the target, you're done. Or like this, you'd say if the lane is one and you found the target, you're done. Then you don't have to track in a hash set all of them. Maybe like the size of the solutions is small enough that this is fast. Anyway, very good. Yeah, keep trying. You don't have to have a CS degree. Do exactly what that guy did, right? Watch some videos, ask questions, and I think it's okay to ask AI. Don't just give it the problem, but say, "Hey, I'm trying to solve this thing. How can you help me out here?" Okay, let's look at one more. Happened upon the fast approach by accident. I started out trying to write a recursive solvability checker, and from there, the idea of undoing operations was fairly obvious. This solution has only a single allocation up front, so it's quite fast, 340 microseconds, even though it's just a single thread. Would rayon make it faster? Let's see. Okay, so we have an equation with a value and args. U16, interesting. Oh, but the value is a U size. Is he going to have to do a bunch of... Okay. Split once, new line, unwrap or split once, colon, and then you parse them. Okay, that's pretty normal parsing, right? I always forget the split run once. I did use nom, though, on mine. Is solvable. If there's only one value, does it equal my value? If there's more than one, value... Okay, so he is doing it the other way that I was talking about, right? Is like... do the operation, remove that total, and if you ever get to like the last number and it's equal to this, you're done. Yeah, it's solvable with concatenation. You probably just do the same things, but then you also do concat. Yeah. I mean, it is a cool solution. Yeah, I don't know that it... I mean, I could try and run a solution, see how how much faster it is. I don't know that it's that much faster. I mean, it's still essentially using recursion. For me, I feel like readability is important, and I'm not very good at it, but like this feels readable. So there you go. I realize we're just solving programming things, so you're probably not too worried about readability here, but sometimes these match arms can get really complicated and make it hard to grok. But again, I think this is a great solution. I don't think there's anything crazy about this. It is a cool idea. Okay, I think that's enough for me. I got to start getting ready for other stuff. But there you go, day 7 in the bag. Definitely easier than day 6. And again, I think it's because this happens sometimes. It's like um the first few days can be like kind of brute forcey, but then they can become very like terse with the edge cases, and that can make a day really hard. And then you get to something where it's all like, oh, if you just know the algorithm, it's easy, right? I'm sure we'll get to one. I'll probably still struggle with it, but there'll be one where you're like, oh, you just use Dijkstra's, and then it becomes, and then you just use Dijkstra's, and it solves the problem. So like the theory behind it becomes relatively simple. You just have to figure out, how to implement Dijkstra's for that case. And this one was the way, right? Is like if you just knew you had to do recursion, it was not hard to solve. Sometimes I over worry about, am I finding the right solution? I think I've said this before. It's not hard to, if you're like, oh, solve it with recursion, just try part 2 with recursion, and if it's only if it doesn't work, then do you try and optimize, right? So there you go. I'd love to see your solutions, so feel free to post them or to fork my gist, and I'll look at your code and review it. And if I have time, maybe I'll try and clean up mine a little bit. But otherwise, we'll talk to you tomorrow.